Hi, this is Maths by Samuel, and today we'll be looking at trigonometry, and specifically the trigonometry of triangles that have a right-angled side. So trigonometry is the branch of mathematics that deals with the lengths of sides in triangles, the angles in triangles, and the relationships between the two. The branch has many identities which can be rearranged in formulas to make them appropriate for the questions we are solving or the problems that we have to solve in exams, for example. For the purpose of the video today, we'll be looking at a right-angled triangle. And as you can see here, it has three sides. As does any triangle, you have a right angle, which is 90 degrees. Then you have two other angles. We have the interior angle here. We have the sides A, which is opposite to the angle. We have side B, which is the longest side of the triangle of the right angle. It's called the hypotenuse. And C, which is adjacent to the angle. It's also next to the right angle as well. Now, there are several definitions for trigonometry in terms of where the triangle has a right angle, but we're looking at three for the purpose of this video. The sine of the angle is equal to the length of the opposite side divided by the hypotenuse. For the cosine of the angle, it's the adjacent divided by the hypotenuse. And for the tangent, it's the opposite divided by the adjacent. A little bit later on in the video, we'll be looking at ways in which you can find either the length of a side or the angle of a triangle when you know two pieces of information, and therefore it's important to show the rearrangement of these equations. So if you make the opposite the subject, you get the sine of the angle times the hypotenuse, and so on for the adjacent and the opposite, as you see here. It's also important to mention that when you go back to Pythagoras' theorem, when you have a right angled triangle, the length of the hypotenuse squared equals the sum of the squares of the two other sides. For example, you see here on the example of the circle where it has radius 1, this side here will represent the cosine of the angle, this side will represent the sine of the angle. So if you take the square of these two sides, you'll get 1 squared, which of course is equal to 1. And you can actually even see where the angle changes as you go through. When you change the side of the angle going through this way, when it reaches 1, obviously the sine of 90 degrees, which will be here, will equal sine 90 will equal 1. Like the cosine of 0, which will be here, will equal to 1. When this angle is 90 degrees, which will it be here, the cosine would be 0, and so on to 180 to 270 to 360 degrees. Now this is very important information when we look at some of the identities of trigonometric functions and how to solve equations. So we're going to do a little example here where we put some of our rules and laws of trigonometry of a triangle with a right angle into place. The adjacent side, the opposite side is 6, the hypotenuse is 10, and we don't know the angle. But crucially, we know two pieces of information to be able to find the answer to this solution. We want to calculate the angle here and also the length of side C. We know the opposite and the hypotenuse, which corresponds to the sine of the angles there that we can compute. Now on your scientific maths calculator, you will need the inverse sine of sine angle, and you'll need to compute sine 6 over 10 or sine 0.6. And this is the answer you should come out with. So the answer, the angle here would be 36.9 degrees to 1 decimal place, but importantly, you never round in the middle of the question. So I'd write it out in full here. I've only done it just to save a little bit of space, but always write it out in full and only do rounding when you get to the end of the question. Now, because we know the angle now, we can also compute C. Similarly, we could also find what C is by using the Pythagoras theorem, which you see here, because it's a right angled triangle, and we know two of the three sides. But we're going to use trigonometry to compute C here. So from our formula earlier, we can remember that the adjacent is equal to the product of the cosine of the angle times the hypotenuse. So if we substitute into this equation, well, we know the angle is 36.9 degrees, it's 36.8 something, as you'll see from the video here. We're showing you an example, a screenshot from my computation on the calculator. Multiplied by 10, you find the length of side C is indeed 8. So here's an example of another problem. It might come up in your exam, it might not, but just to show you the relationships between the sine, cosine and the tangent. We want to express the tan of the angle in terms of sine of the angle and cosine of the angle. So how do we do that? Now, if we recall from our formulas over here, the tan of the angle equals the length of the opposite side divided by the length of the adjacent side of the triangle. So how do we express this in terms of the sine of the angle and the cosine of the angle? Well, we have to rearrange these equations, and we'll do like so. We'll make, for the sine of the angle, we'll make the opposite the subject. So the opposite equals the sine of the angle times the hypotenuse, and for the cosine we'll do the same. So, now how do we express this in terms of the tangent? Well, we know that the tangent of the angle is the opposite over the adjacent, so we can just shoot these values into the equation below. So the sine of the angle times the hypotenuse. So simply by inspection we can see that these two hypotenuse terms cancel out because you're multiplying on one on the top of the fraction and you're dividing on the bottom, so they literally cancel out. So therefore we can conclude that the tangent of the angle is equal to, and this is a neat little identity. So example 2, what we want to do here is using the same rules we've used before, but this time we've given the angle of the right angled triangle. We're also just given the length of the opposite side, which is 8. So how do we compute B and C? Well, in order to compute length of the hypotenuse side B, we see here we have the opposite 8 and the angle, and these are the three components which make up or add to the sine of the angle. So basically this is what we would do to compute the answer. We would do equals the opposite, which is 8, divided by B. Or to rearrange this, which we basically do, is equal to B. And it's literally just a case of solving this in terms of B. And this is the answer you get. When we do the computation of sine 30, we get 0.5. So B is therefore equal to 8 divided by 0.5, which gives you 16, the value of B. So now the last thing we want to do with this triangle is to find the length of C. Now, there's a few ways we can do this because we have 3 of the 4 elements of the triangle here. We have the angle, the opposite side, and now the hypotenuse. But we can do it by Pythagoras, but for this example we're going to use trigonometry again. So we can also do the tangent because we see we have 8, 30. So what we compute it, we have the tangent of 30 is equal to the length of the opposite side, which is 8, divided by. Now, by computation of the tangent of angle 30 and rearranging in terms of C for this equation, this is what we would get as our answer. So the square root of C, for this particular example, is actually the root of 192. And just by inspection, we can double check using the Pythagoras theorem, which we'll do so now. If this is to be true, therefore, 16 squared would have to equal 8 squared plus, which would give us 256 is equal to 64 plus 192. And off the top of my head, 64 plus 192 is indeed 256. So yes, this is the correct solution. So for the purpose of triangles of a right angle, we'd look at some of the trigonometric identities and definitions today. But obviously it gets more complex than this. You can start to look at the sine rule, which doesn't mean the triangle has to have a right angle. It basically looks at the length of sides, and also any angles within the triangle. But you normally have to be given 2 or 3 pieces of data. We can look at that a little bit later on, but if there's anything you'd like me to include in a future video, let me know. And once again, thanks for watching.